Assalamu alaikum. It's our 12th lecture of Principal Methods and Applications of Nuclear Tracks. And in this lecture, we will discuss about some amazing aspects like fluence. So what is basically the fluence is? So fluence is basically the number of particles that passing through per unit area, and it is denoted by this psi. And the unit of fluence is per centimeter square or per meter square, because fluence is the inverse of the cross section as we discussed in previous lecture. Understood? That's why the fluence has the units of inverse of the cross section, as the cross section has unit of centimeter square or meter square. So that's why the fluence has a unit of per centimeter square or per meter square. Okay, it is basically the number of particles that passing through per unit area. Also, you can define the fluence is defined as the total radiant energy passing through a small transparent imaginary spherical target containing the point of interest divided by the cross-sectional area. So fluence is basically the total energy that radiated after your projectile and target hits. Okay, you know that there are two objects, one is projectile and one is target. They have to collide, either they have to scatter or fully interact, either they graze. Okay, so influence, this is basically total radiant energy passing through a small transparent imaginary spherical target containing the point of interest divided by the cross sectional area. So 1 divided by cross section is equals to fluence, which is denoted by psi. So now move on towards an important topic, which is the grazing angular momentum. So what is the grazing angular momentum? As the name stands for angular momentum, so the grazing angular momentum basically refers the maximum angular momentum of a projectile in a nuclear reaction in which the projectile that is coming just grazes the surface of the target. What is meant by grazes? As you can see from this figure, this is your projectile which is coming, and this is your target nucleus, and projectile is coming just grazes, means just touching from the edge of the target and move further. Okay, so this is so called as grazes. So in grazing angular momentum is basically the maximum angular momentum in which the projectile in a nuclear reaction at which the projectile just grazes the just you can see just grazes the surface of the target nucleus. Okay, without being fully captured, or you can see without being fully captured or undergo any reaction, because when they just grazes the surface, touches from the edge of the surface, then there is no probability of fully interaction. Okay, that's why in this scenario your particle is not fully interacted, or you can say that not fully captured. Okay, or not undergo any reaction. So reaction only happens when there is fully interaction between the projectile and target. But in grazing angular momentum, projectile just grazes the surface of the target. That's why in this no specific reaction involved, like fission or fusion not involved in this case. And in this scenario your projectile only involve in this scenario your projectile is only deflected due to the coulombic force, because you know that when particle is just grazes from the target, there is some coulomb force of the target. That's why your particle may deflected somehow by the influence of the coulomb force, but there is no involve inclusion of fission or fusion reaction. Okay, so you can also see that it is often discussed that grazing angular momentum is important because it defines the maximum angular momentum. As the name stands for angular momentum, that's why grazing angular momentum basically refers to the maximum angular momentum, and it is denoted by this symbol L max, means maximum grazing angular momentum. Okay, and when your grazing angular momentum is greater than the angular momentum, then particle will interact with the nucleus, then particle fully interact with the nucleus. But when your angular momentum is greater than the grazing angular momentum, then the scattering process happens, means no reaction. Okay, so in order to have a reaction between target and projectile, your grazing angular momentum must be greater than or equals to the angular momentum, then the particle will interact with the nucleus. And the formula for the maximum grazing angle is this: 2 eta eta, which is the Sommerfeld parameter. Okay, it is the Sommerfeld parameter multiplies by ECM. What is ECM? ECM is the center of mass energy divided by VC, which is the Coulomb energy, multiplies by 1 minus VC by EM power 1 by 2. Okay, so this is basically the formula how you can find the maximum angular momentum if there is center of mass energy and Coulomb force, Coulomb potential is given. If there is no eta, there is a formula of eta we can also discuss in further in this video. Okay, so now what is this eta? Eta, as I told you, this is the Sommerfeld parameter. Basically, Sommerfeld parameter basically describes the strength of the interaction. Okay, strength of the Coulomb interaction between target and projectile. As you already know that what is Coulomb potential, we discussed in previous lecture. So basically Sommerfeld is related to the strength of the Coulomb interaction. In Coulomb interaction, you know that there is two parameters involved. One is projectile and the other is target. Okay, so Sommerfeld parameter is basically the strength of Coulomb interaction between projectile and target. Here is the relation of the Sommerfeld parameter, in which Zp, which is the atomic number of protons, Zt, which is the atomic number of targeted particle, multiplies by E squared divided by h cut mu. Okay, whereas h cut is the Planck's and v is the velocity of the particle. Okay, projectile particle. Okay, so this is Sommerfeld parameter, and it depends upon, as you can see, that Sommerfeld parameter only depends upon the charges, between the charges of the interacting particles. This is interacting particle, this is another interacting particle. So Sommerfeld parameter, as in Coulomb potential, both depends upon the charges of interacting parameter and their relative velocities, inversely proportional to the velocity. If the particle velocity is high, their Sommerfeld parameter is very low. Okay, inverse relation. So higher charges are slow speeds. Okay, means higher charges, if there are more charges, they are slow in speed, and the strength of the Coulomb interaction is more, and thereby increases the angular momentum. So there is a relation. You can only justify that if there is more number of charges, then definitely there is less speed, means less velocity, and if there is less velocity, then the strength of the Coulomb interaction, means Sommerfeld parameter, is high. And as the Sommerfeld parameter high, the angular momentum is also got increase, because the angular momentum has a direct relation with eta, as you can see in the formula. Okay, so here is a problem which we are going to solve for this topic. Consider a proton with a gold nucleus, whereas the atomic number of gold is given 79, and the center of mass energy is also mentioned 10 meter mega electron volts. The radius of interaction is also given 8 multiplied by 10 raised to minus 15 meter, and the Coulomb potential is also mentioned here, 5 mega electron volts. Calculate the maximum grazing momentum. Means you have to find L max, which is the maximum grazing angular momentum. Okay, so you know the relation of the maximum grazing angular momentum, which is 2 eta ECM by VC, which is the center of mass energy divided by Coulomb potential, multiplies by 1 minus VC by ECM power 1 by 2. So in this scenario, VC is given, ECM is also given, but the only unknown factor is the eta, which is the Sommerfeld parameter. So first of all, we have to find the Sommerfeld parameter eta, and then we have to put that into our main expression. Then we have to find the L max. So whereas the eta is concerned, we know the formula for the eta is basically Zp multiplied by Zt into E square divided by h cut and V. Okay, so simply putting the value of Zp, which is Zp is proton, means 1 multiplied by 79 multiplied by 1.6 into 10 raised to minus 19 square divided by h cut, which is the value is 1.054 multiplied 10 raised to minus 34, and the velocity, but the velocity is again unknown. So how you can find the velocity? We know that the relation of energy, kinetic energy, which is equal to 1 by 2 mv square. Move 2 to the other side, now your velocity becomes equals to 2e by m. So taking under root, so velocity v becomes equals to under root of 2e divided by m. So energy is already given is this 10 mega electron volts, and mass is also given, because the projectile particle is proton, we have to put the mass of proton here. Okay, so after putting the mass of proton, energy here, you can easily calculate the value of V, and this is approximately 3 multiplied by 10 raised per 7 approximately it will comes, and you have to put that value here. After putting that value here, multiply this, you will get the value of eta. Putting the value of eta here, you can easily get the relation of L max. There is some important facts about the grazing momentum is the upper limit for the angular momentum at which the projectile can still interact with the target. It depends upon the Sommerfeld parameter. Okay, so basically the grazing momentum is the upper limit in which you can see the at in which the projectile is turned, because you know that the projectile will have to strike the target. So in this, the projectile can still interact with the target. Basically the interaction of projectile to the target basically depends upon the Sommerfeld parameter in grazing angular momentum. Okay, so how it depends upon the Sommerfeld parameter, and it also depends upon the center of mass energy and the Coulomb potential, because you know that in the formula of the grazing angular momentum there are three aspects. One is the central of mass energy, other is the Sommerfeld parameter, and the Coulomb potential. And as the energy increases, Coulomb potential decreases. Okay, because there is inverse relation of Coulomb potential and energy. So as the energy increases, Coulomb potential decreases, and the grazing angular momentum increases. As you can see that as the energy increases, then your Coulomb potential decreases. As the Coulomb potential decreases, your grazing angular momentum increases, because we in this scenario energy of central mass energy must be greater than the Coulomb potential. If your center of mass energy is not much greater than the Coulomb potential, then there is no reaction. Okay, then the reaction cross section equals to zero. There is confirmed that the center of mass energy is always greater than the Coulomb potential. So that's why in this case, when the energy increases, Coulomb potential decreases, and when Coulomb potential decreases, then the decreasing angular momentum increases. Okay, so there is another problem. A proton Zp equals to 1 is incident on a oxygen, okay, a nucleus where Z is target atomic number is also given, which is 8, and the center of mass energy is 5 mega electron volts, and the Coulomb potential at the interaction radius is 3 mega electron volts. Okay, and the Sommerfeld parameter eta is equals to 1.2. Calculate the maximum grazing angular momentum. So this problem is also very quite easy, so you can do this by yourself, just putting the value of Zp1, Zt8, and multiplies by 1.6 into 10 raised power minus 19 square, divided by, okay, to finding eta. But here is eta, you can see, already given, so you have to just use the expression of the grazing angular momentum, which is L is equals to 2 eta multiply 2 multiplies by 1.2 multiply by ECM divided by VC. ECM already given, which is this, divided by VC multiplied by 1 minus VC divided by ECM power 1 by 2. All the expressions are given in this problem. You can easily find in two steps the grazing angular momentum. As we already describes the grazing angular momentum, now we have to discuss about the grazing angle. What is grazing angle? Okay, as the name stands for angle, so this is must be the angle by the grazing. Okay, as you know that what is grazing, in which the projectile just grazes the surface of the target. Same scenario is this, when your projectile just grazes the surface of the target, the angle it makes with this, that is called the grazing angle. Okay, so the grazing angle interaction is a weak Coulomb interaction. Okay, in which the interaction is weak, means just touches the surface, just grazes the surface. That's why the interaction is weak between the energetic particles. Energetic particles are projectile and the target. Okay, as few mega electron volts, very few. Okay, interaction, and you can say that in this case the energy loss in the kinetic energy is very low, because there is low loss of in the kinetic energy. Why low? Because in this the interaction is very weak. So as the interaction is very weak, so there should be kinetic energy loss is very low. Okay, so the relation of the grazing angle is theta gr, which is the grazing angle, equals to 2 tan inverse of eta divided by L max, eta which is the Sommerfeld parameter, divided by the grazing angular momentum. Okay, so you can also define the grazing angular momentum refers to the angle at which the projectile approaches interaction or scatter, because when your projectile just hit the surface of the target, then there is just opportunity of scattering. Okay, that's why when grazing angle basically refers to the angle of projectile that approaches interaction or scattering. Okay, the angle is significant on nuclear reaction because it corresponds the trajectory where projectile just grazes the surface of the target, means just touches the surface of the target, often without fully captured or repelled. Definitely when there is fully interaction, then there is possibility of repulsion, but when there is no fully interaction, because in this scenario there is no fully interaction, so when there is no fully interaction, then there must be no fully captured of particles and nor fully repulsion. Okay, that's why the grazing angle is a critical angle at which the projectile comes towards it to the target, means very close, just touches the target, which still being influenced by the nuclear force. Same concept as we discussed in the maximum grazing angular momentum. Okay, in this scenario also some of the your projectile influence some force due to some the nuclear force, means the Coulomb force. Okay, so what is the relation is the smaller grazing angle correspond to more direct collisions. If your grazing angle is small, then there is more direct collisions, means interaction is direct, means they are fully interact when your grazing angle is small. Okay, in order to grazing angle perfect, whereas larger grazing angle indicates the projectile just skins the target, means just grazes the target, just touches and passes, means scatters. So greater the grazing angle, more will be the interaction, direct interaction. But when the grazing angle increases, okay, larger grazing angle indicates that the particle project, means the projectile just skims the target. Okay, here is a problem related to the grazing angle. Okay, in which a proton zp equals to 1 is colliding with the carbon particle with which having zt targeted atomic number is 6, with Sommerfeld parameter is again given eta equals to 1.5, and the maximum angular momentum is now given, which is the 3h cut. Calculate the grazing angle. You have to find the grazing angle. So you know the formula of the grazing angle, theta is equals to 2 tan inverse of eta divided by the L max. Eta value is given here 1.5 divided by L max value is given, which is 3. H cut is basically the state. You have to just use the number, which is 3, so you will get the answer for the grazing angular moment and grazing angle, and that is 53 degree. This problem you already solved in previous. Okay, so that's all for 12th lecture of principal methods and applications of nuclear tracks. Okay, so if you have any further question, you can leave the comment below. I will definitely answer your questions. Okay, so these topics are very important for papers, so you must have to go through these topics. So till then, take care. Allah Hafiz.